Cool. So we're just about ready to go. Welcome, everybody, to the very first Lightning Talks round of ReactJS Dublin. This is pretty exciting for us. For those of you who've been here before, you know that we generally have 2 or 3 long-form talks. This time we have 9 very, very short talks, which means that the chance for something to go horribly wrong between talks is like 3 times more than it usually is, which is brilliant. My name's Cian. I'm a software engineer here at HubSpot, and I work primarily on the front end with React. We still do have some seats if anyone is left. Looks like we're all good. Cool. If you are interested in giving a talk, either a Lightning 5-minute talk or a longer form one, please do get in contact with me or come send us a message on the meetup.com page, and we'll help you figure out the topic if you need that, and we'll help you workshop the talk if you need that too. ReactJS Dublin, all the events so far, including this one, have been sponsored by HubSpot, whose office we are currently in. They sponsor food, drink, organization, location, and pretty much everything that goes into the meetups. That's pretty cool. Here in Dublin, we build several products, including our free email marketing tools, much of our email product, some of our infrastructure, some e-learning platform, and some cool machine learning too, which is pretty cool. We made the decision to move to React for all of our front end about 2 years ago. Using React, we sort of settled on Redux, which is pretty cool, as a store. And almost all of our older code has been refactored, although I somehow suspect that, like most organizations, there'll always be some interesting stuff left. We are currently hiring for all sorts of things, including these positions. If you see anything that you're interested in, either chat to me or anyone else who looks like they're a HubSpot employee, and we'll answer your questions. So let's get going. Our very first talk is building a React app with Create React App from Eibhlín.
Hi, I'm Eibhlín. So I'm going to show you how to make a React app, a live source-controlled React app in like 5 minutes-ish. Cool. So would you? I need a human mic stand here because I'm going to type. Thank you. Cool. So pretty much before, like, what you need to get set up is you need to have.
Let's make sure we can see what's going on.
Sorry. All right. Cool. Great. Okay, so before you get set up, get started, you need to have a Heroku account and install Heroku command line tools. Also a GitHub account and the GitHub terminal tools, and you need Node.js. So the first thing you're going to do is npm install create React app. I already have that done, so I'm not going to run that command. And then, so what you want, like, that is the create React app. So then you want to actually create an app. You just run this command, create React app, which actually takes like 2 to 5 minutes. I'm not going to run that. I already ran that. So I'm going to like take you to the next step. So in here, we're going to create a Git repository. And then you're going to make a Heroku project. So so that's like the name of your app, and that's what it'll look like when it's live. That's like the URL that you give it. And then we use a build pack, which is here, and I can like give anybody a link to it if they need it. So you run this command, and this takes like, oh. Hang on. Okay, so that is really short. So then what you want to do is add it and commit. And then push to Heroku. Thank you. Great, so this just takes 3 minutes. Yeah, so pretty much like the reason we like came about this is we were doing a workshop here, and we had some like college students come in, and we wanted to like get them set up with like a working web app that they could like contribute to themselves like really quickly. So we found like this way to do it, and it's like source controlled with GitHub and like really easy to configure, so that like configuration process is just like not there really very much. Cool. So this is just taking a minute. So this obviously depends on your like internet speed and everything as well. Okay. Just trying to keep it within the 5 minutes. So, yeah.
Can you tell us like what this kind of sets out for?
Yeah, so this is setting up your app with Heroku. Here it is. That's your like live web app straight away. So what we're going to do now is like configure it with GitHub. So if you make like a GitHub repo, and then you go to Heroku, and these are like my previous apps. And when you reload it, we can see as first app. Cool. So when we go in here, so what you can do then is like, so if you want to like, whenever you like commit to GitHub, then it automatically like commits to like and like makes your app live as well. So if you go to the deploy, and you choose GitHub as your deploy method, and then you find your repo and then connect to it, and then also click enable automatic deploys. That should set that up. You want to like add your repo as well here. Okay, and then if you do npm start, that gives you like a local version of your web app. So then you can like do sorry, that's a bit slow. So if you want to make any changes to your web app, just open it and say you go to app.js and so save that, and what's cool is that it hot reloads the page, so you don't even have to do anything. And then just to make that live then on your actual website, so add that change. And so this change actually like it's not instantaneous. So when I refresh it, it's not actually going to work for like 30 seconds, which sucks. But if you want to like actually copy that link into your phone or something in like 30 seconds, it'll have the new title. I'm not going to wait around for that though, because this is like a 5-minute presentation. I'm probably already over my limit. But yeah, it actually works, I promise. Cool. So, yeah.
So up next, we have John to speak with about building a small React app. And do you need me to?
No, it's good. Thank you. Hi, so my name is John Maguire. I'm a software engineer working at One Page CRM. So we're a small company based in Galway. So I'm just going to be talking about building a small React app. So sometime last year, we noticed that all of our views in React or in Ruby on Rails were getting really, really big. They were getting kind of unmanageable and taking a long time to render. So we decided we were going to try and break them up into smaller components. So React kind of fit the bill for this perfectly. Yeah, so when we started breaking up into smaller components, we noticed we got faster front-end rendering, and it was also an excuse to refactor these large old views into smaller components. So if you want to get started with React, it's kind of this talk's kind of where to begin, how you go about it. So first of all, in your view, you need to create a mount node. So this gives the React component a place in the actual HTML view to render all of its code. So the React component is written in JavaScript, so we need a place in the actual HTML where the React component can spit out all the HTML that it needs in there. So as you can see then at the bottom, we find the React component in JavaScript, and then we render the component in there. So what is an actual component? So a component can be thought of as any part of the UI. So a component it spits out one DOM node. So if you look into your HTML code, any part of that HTML code that is one DOM element, so a div with lots of text or a text field or anything like that, can be thought of as a component and be extracted out as a component. So if we look, here's a small component here. So this is just a JavaScript class that extends the library React component. This will render the div DOM node and will spit out the text hello world. You can see when we call the hello message class, we give it the property, we pass in the property name with the value world. So this allows us to have dynamic properties within the component. So if this is a larger application, you could do something like call the database for a user's name and have this then when the user logs in, it would say hello, whatever the user's name is. So React components have a parent-child relationships. So because they're small components that only release one DOM node, you have to have a parent component that will render all of the child components. So a parent component is what we would actually render to the HTML mount node, and it would then worry about rendering all of the different child components. So if you had a massive form for your user interface, what you would do is the parent would be the form, and maybe each text field would be a child component. So one last thing I want to talk about is CoffeeScript. So we use CoffeeScript for writing our React components. Most people use JSX, but we find the CoffeeScript is actually it's a lot nice. Well, we find it a lot nicer. It gives you lots of different nice functions like arrow functions. It uses indentation rather than curly braces, string interpolation, different things like that. So here's an example of the two. So with JSX, you can see that we have things like curly braces. It also uses a combination of HTML and JavaScript. So my editor here got confused, and everything after the last slash became a string. Whereas with CoffeeScript, it's all written in CoffeeScript. I think it looks a lot neater, and I think it works quite well. So to round things up, React is great for new and existing apps because it can just stick straight in anywhere into your view. You don't need to rewrite any of your application. Components are just parts of a UI. Props are used to populate components with data. A parent component contains many child components, and that keeps everything separate and much easier for things like debugging and updating a certain part of the UI or whatever. And give CoffeeScript a go because I think it's actually really good and it'll make your life a lot easier. So there's my comments. Okay, thanks.
So next up, we have Richey to tell us about Eslint.
Thank you. No, I'm good. Hi guys, my name is Richey and I work for a company called HMH, and I'm here to talk to you about Eslint. What is Eslint, I hear you ask? Well, Eslint is a linter. What is a linter, I hear you ask? A linter is a thing that looks at your code and tells you how to make it less terrible. So, let me just start off. Good error messages. I'm sure you guys have all written JavaScript and gotten a message like, cannot find property name of undefined. It's like, great, that's really useful, thank you. Or, you might have got a message from IE, something like script error 1407, and it's like, okay, what is that? I don't even know. So I'm going to talk about other languages that have really good error messages first, just so we can get an idea of what a good error message is. So this is Elm. Elm is something that actually compiles down to JavaScript, but it's kind of based on Haskell and other sort of things. So what happened here is when you're passing in your parameters to this function or whatever, you actually misspelt the parameter phone number, and it's like, oh, hey, you might have misspelt that. You might want to fix that. And it's like, oh, thank you. That's really helpful. Thank you. Now we'll move on to Rust. And with Rust, it's kind of like, oh, when we compile this, we find out it's undefined. It's like, cool, well, there's these other things that you might actually want to use. They might be the kind of thing you're looking for. And it's like, all right, great. That's really helpful. Thank you, Rust. So Eslint isn't quite as good as those things, but it gets you some of the way there. So you're missing a semicolon. Put it in. It's like JavaScript has semicolons. I know that's a controversial opinion, but let's go with it. So here's a slightly more, kind of reasonable example. You've got return. It returns x plus y. You're doing this other added thing afterwards. It never gets called. It's useless. You may as well take it out. Yeah, it's kind of boring. Like that's just all annoying JavaScript stuff. It's not really that interesting. We're all here writing React. We might be using ES6, I don't know. So with those sort of things in mind, how can Eslint help us? So I'm sure we've all had those things like, why doesn't this work? Why doesn't this work? And it's like, oh, okay, yeah, I'm imported it or whatever. So this is simple enough. It's like you're trying to import your math.js module. You've got the path wrong. You might have misspelled the module name, whatever. It'll tell you. That's really nice. So here's some a little bit more, meaty. So in React, you can either write, components as classes that have state, or you can write them as pure components. Ideally, you'd write them as pure components because less can go wrong. So Eslint is like, hey, you're not doing anything that deserves to be a stateful component, so just change it. And you do, and it's great, and everything's great. So next part. React has this idea of prop types, which basically kind of really shores up the contract of your component, with the rest of the app. So it'll say, okay, you've got this name thing. It's like, what is this name? Like, what am I meant to be passed in here? So on the next thing here, we can sort of see, if you look at first name here, because we kind of did a bit of a refactor and changed things up, it's like, it's a string, and we need it. So, this component's not going to work unless you pass it in. Then we're like, oh, well, maybe we want a last name too. And it's like, it's also a string, but you see, it doesn't have this is required thing. So we're like, okay, well, we'll pass the default value, and the last name becomes Doe. So Eslint is telling us like, oh, well, maybe you should really, try and shore up your parameters as being passed in, so everyone's just really clear as to what's going on. So here's another part. If you have a stateful React component, you can set state on it, and there's different lifecycle functions that you've got, like component did mount, component did update, and so on. And sometimes it's kind of dangerous to set state when these lifecycle functions are being called. So Eslint will tell you, it's like, ooh, I don't know if you should do that. That might be a little bit dangerous. You might want to double check what you're doing there. And it's just kind of a handy reminder to be like, oh, you know what? Yeah, I'm being an idiot. I won't do that. So, and that's it. It's just like with Eslint, it just makes your life a little bit easier when you do that inevitable pull request. Everyone will be like, what the hell, Richie? What the fuck? Oh, no F-bomb there, sorry. So, yeah, and that's it. It's like I'll drop the mic, but I'm sure these guys are expensive, so I'll just hand it over.
Cool. Who do we have now? Esdras to tell us about Firebase and Redux. Somewhere. Here we go.
Hi. Yeah, my name is Esdras. I'm going to talk about Firebase and Redux. First, what is Firebase? Firebase is a service owned by Google and has a set of tools to help developers to build and grow apps. My favorite features are the storage. Using the storage, you can provide files such as songs, videos to your users. Authentication with a few lines of code only. You can add any provider like Google, Facebook, Twitter, and even your custom authentication. And my favorite database, the Realtime Database, that is a non-SQL JSON-based database. And what is so special about this database is that it's very fast and it's real time. The data synchronization works. If you have a listener in a node, in a piece of data, and this piece of data changes, immediately you get this new data in your device. It doesn't matter if there's 1,000 of devices connected to the same data, there's 1,000 of devices to get this update. And it's these devices, these clients, they access the data straight from the client straight to the database. There is nothing in the middle. It's why it's so fast. And it's safe. You can write like a ton of different rules to make sure your data is only available to your users and the right users. And how to combine this power with Redux. If you look online for Redux and Firebase or Firebase and React, you will find the React Fire library. There is a library that is not more supported by Firebase. And this library works like it gets the information from Firebase and then puts this information inside the component state in React. And then how would you add a Redux here? You had to add later, then your component would tell Redux. But this is bad because Redux doesn't know what is going on here. And this is not the goal with Redux. Redux has to have the control of the state of the application. Another common mistake you find online is put React in the middle. Your components, they fetch information from Firebase, they add this information in Redux, and then as an action, then Redux repopulates your component to this data, and then every time this data changes, you need to tell both Firebase and Redux. And this is even worse. Your components are acting like a middleware. It's overloading your components. And then there's this approach where you have your components ask for data to Redux. Redux go to Firebase, gets this data, and then Redux sets this data as props to your components. This is good because Redux is taking care to their actions, and Redux is in charge here of your application stage. And how this is done in details. Imagine if you have a blog and your React component asks, you have this list of blog posts, and your React component dispatch a fetch post actions to Redux. Redux goes to Firebase and set this listener, and immediately it gets back all the posts. And after that, your Redux set all these posts, pass all these posts as props to your component. And imagine you have a plus button where you can add a new post to your blog. So to create this post, your component, you go dispatch this create post action to Redux, and Redux save this post in Firebase, and that's it. You don't need to tell your component about this new post, because in the very moment you save in Firebase, this listener, sorry for this animation, this listener will be called again, and would tell Redux about this, and magically Redux will tell your component about this new post. So Redux is in charge here, and everything is summarizing your listeners, so everything is much easier when you combine your Redux, React, and Firebase like this. And that's it.
Personally, I was a huge fan of the animation, and I'd like to thank you for including it. It's very good. So when we were planning the timing for this, we kind of budgeted for like me dropping the mic and smashing the screen and like jumping for joy because of animations. But it turns out we're doing pretty well. So we have one more speaker, and then we're going to take a quick break. Sara is going to tell us about Immutable JS.
Hi everyone, I'm Sara, software engineer here in HubSpot. Just a moment. Can I remove this part here? Okay. It doesn't matter. So just a few words about Immutable JS. This is probably going to be clearer to guys who already use React, who have some experience with it. So Immutable JS is a library which basically makes our data immutable. So what is immutable data? Very simply, one immutable object, once it's created, it cannot be mutated, which is pretty obvious. What happens instead? So in the last line here, we have an example. So we have an immutable map1. If we try to set some new value, map1.set, that map is actually not mutated. It's just duplicated into map3, and map1 is staying as it was. So what are problems with mutable data? Why should we care about that? So one example is functional programming. So when our objects can be changed anywhere in the application, they can be changed in one place and used in completely other place, and you may not be aware that something actually changed here. So your data is not persistent, and that's bad because it can cause bugs. Why immutability works well with React? So if you're using Redux, an example, immutability can bring you a performance boost. So that's because, as you probably know, React is re-rendering the whole component every time your data changes, so every time your state or props change. So you can use pure render mixin or React.pureComponent in order to not need to write your own should component update. So that's useful because with implementing should component update, you will prevent that your whole component re-renders every time, and you want to re-render it only when some piece of data changed. The problem here is that should component update does only a shallow compare. So it works well with a very simple data. But what if you have complicated nested data? It can cause false negatives because it's not going to do a deep equality check. So solution for that, you can either implement should component update and do a deep equality check, which is bad because it's slow. You have to go, you may have a map with list inside, with whatever, which is not good. You should strive for a simple state, of course, but sometimes you just have a list of data. Another solution would be to use immutable objects. So they simply give us cheap comparisons of nested data. So why is that? Because if an object is immutable, comparing two objects by its reference is going to tell us is it changed or not. What are cons of using immutable approach without some external library? So why would we use a library like Immutable JS? So very simply because immutability is by itself slow. Immutable JS is optimized, and it's probably going to do that better than you are. So Immutable JS gives us immutable persistent data, which also uses structural sharing. So once data is created, it cannot be altered at any point. Any new collections is going to be created from a previous collection and mutation, but our initial collection stays as it was. Structural sharing is that optimization I mentioned earlier. So any new collection is created using as much of the same structure as the original collection as possible. So it's reducing copying to a minimum to improve its performance. So it's not going to copy the whole data tree. It's going to reuse whatever it can reuse. So copying immutable objects means actually that you're just making another reference to it. You're not copying the whole object, which brings memory saving as well. One other cool thing is basically a free feature Immutable JS gives us, which is if your application needs a history of changes, or if you need to implement undo redo. So at every point of the time you will have very easy and cheap access to your previous object. You should have in mind that there is a trade-off. So it's never black and white, and you should never say, okay, I'm going to use Immutable JS for every single object in my application, or I'm not going to use it at all. So if you have complicated nested data, if you're using Redux, if you want to implement should component update or just use pure component, you probably will gain a big performance boost by using immutability. But if your data set is very small and simple, you should probably think about that because you may not need it. Here are some alternative libraries. So Seamless Immutable and Immutability Helper are something you can consider instead of Immutable JS. And here is a link. I recommend watching this video. It's about an hour long, but it goes very deep into explaining how Immutable JS are implemented and what do they do. So if you want to find out some more information, that's that.
Thank you very much. So let's take a quick 15-minute break to top up on beer, or if I don't know if there's any pizza left. If there is, let's grab that. And I'll be back here in 15. Okay, we're about to get started once again. I hope you all enjoyed your very, very, very short break. Next up, we have Eugene to tell us about building with React Native.
Thank you. Hi, so the official talk of this talk is building with React Native. But to make things more interesting, I decided to give it a subtitle. So how far can you get without Xcode, Android Studio, JavaScript, or Objective-C? Okay, so let's get started. A little bit about me. My name is Eugene. So I started my career as a backend developer, and then I moved to the front-end stack. Worked for a couple of smaller and bigger companies. Currently, I work with an awesome guys from Logograph, where we specialize in detecting brands and products and images and videos. So let's start. Building native apps is hard. The sheer amount of things you have to learn is overwhelming. First of all, every platform has its own IDE. So for Xcode, for iOS, you have Xcode, and then for Android, you have Android Studio. Also, you need to learn a new language every time. So be it Java for Android, Objective-C, or Swift. I don't know much about mobile development, sorry. And on top of that, every platform has a set of APIs that are similar in functionality, but have different semantics. So you have to relearn it every time, which is not helping. To continue that list, iterations are very slow in native development when you compare it to web development. So if you want to test the change in mobile application, you need to recompile the entire app. There's no concept of live or hot reloading. And as the time goes by and your app grows, your iteration time gets slower and slower. Besides developer experience, there's no way to deploy the code quickly. So currently, it takes around 2 days in the App Store just to review the app. It's a bit better in the, It's a bit better in the Android Play Store. It's like 3 hours, I think. For people that are in the industry a bit longer, they might be sitting there and thinking, wow, that's nothing new. The problem was solved before, and it was and it wasn't. So let's look at the previous attempts. There were 2 big players that appeared back then. So there was Cordova PhoneGap and Xamarin. They both took different approaches. Unfortunately, neither of them found wide adoption. One of the reasons was that it all happened in the early days of smartphones. The CPUs and RAM was quite limited, and it was hard to simulate smooth experience of the native applications. Ironically, the final blow was dealt by Facebook. So that's when Mark Zuckerberg said that HTML was the worst bet that they made. So that kind of threw the market off a bit from that craze. So for comparison's sake, let's look at the way PhoneGap worked. You had your iOS Android app that wrapped a full-screen web browser, that wrapped your web view, that controlled your user interface. So with this type of architecture, you had no choice but to approximate native components. So no Cordova app could match the look and feel of a real native app. The little things like scrolling acceleration, keyboard behavior, and navigation would add up to create inconsistent and frustrating behaviors or experience for the user. So React Native took a better approach. I love this animation. They had access to much more powerful hardware, but what they decided is to decouple the JavaScript engine from the web browser, and that was the first right solution. It allowed you to use best of both worlds, so speed of development and simplicity of JavaScript, while talking directly to the native layer on every platform. So hopefully, at least now you're interested to give it a try. How do you get started? Introducing Exponent. Have anybody heard of the tool or used it? Big hands. Cool. 5 people. That's the way to go. Exponent is a tool chain consisting of a desktop app, desktop host app, and a mobile client. Desktop app is used to package your JavaScript and publish it, while the mobile app is used to pull the published packages on your phone. This setup allows you to have those nice features like live reload or hot reloading enabled by default. Exponent also makes native development feel as fast as web development. So if you're used to all those features, that's the way to go. So another great feature that Exponent provides you with is easy sharing of the apps. So whenever you start your project, the Exponent will give you a link, a URL that you can share with your colleagues or friends or whatever who would like to see the app running on their phone. And that would happen in minutes. Compared to that to TestFlight, I don't know if you worked with TestFlight, but that's the application that Apple is providing for beta testing. It takes at least half an hour just to publish your app there. So Exponent ships with a growing list of high-quality components. These components are tried and tested to work equally well on both Android and iOS. Last but not least, it's free and open source, so there's nothing stopping you from just trying it, at least. Okay, I'm a bit over time, but let's do a quick demo. It's pre-recorded. So I'm going to explain what's going to happen. This is the simulator running on the left, then that's the packager, and that's the Sublime editor with the code loaded in it. So what's going to happen there is that I'm opening the Exponent client here. I'm selecting the app that I want to run. The packager starts packaging up the application. And you can see the app running in the application. So what I'm going to do now is copy the example from Exponent's website that actually is more complicated. It's going to run the camera app. And you can see I copied, pasted, saved. It's reloaded the application already. Just to make it a bit more interesting, so this is a camera roll application, and I decided to replace it with the camera app. So there you go. And then just to edit it here, instead of showing pick an image from camera roll, saying open camera, I want to show it only if the image is not loaded, so if there's no shot that is made from camera. And if there's a shot from camera, then I just want to show it and say, hello, React Native Dublin. Again, hit save, loads. Hit open camera. Grab it, and there it says Helric. So that's about it. This is the link for Exponent. This is my Twitter handle. If you want to load that application on your phone, just follow me, and there's a link over there. Thank you. Thank you.
So next we're going to have Alan tell us about building newslinn using React Native.
Evening. So my name's Alan. I'm developer and co-founder at newslinn. We're a team of 3 people, 2 developers, 1 designer. And what we are at our core is a network of verified journalists. We develop apps for citizens to help them share photos of incidents that are happening around them directly with our network of journalists. And we provide content verification of the data that's actually coming in through from the citizens through the app. We have tools for journalists to receive, verify, and manage that content in the form of a journalist dashboard. We have a business product that is for managing a business's presence on the network. PR agencies or businesses can have this, and it essentially enables them to have a presence on the same network as the thousands of journalists that we have there. Journalists can subscribe to the topic areas of interest that they want to receive updates about those businesses from, and they can get the information, the data, in a structured way with high-quality assets available to them. A bit about our tech stack. We use a lot of tech at the moment. We're refactoring a lot of it to use React, both from the app end of things and the web. But our app is React Native. Our Press Pages product is in ReactJS. And we use Django CMS and the Django REST framework to actually do the communication between the React Native app and the web end of things. We use Framework 7 for in-browser journalist profiles. And we use Python and scikit-learn for actually the machine learning and rules verification engine of the content that comes in through the platform. We got part funded by Google Digital News Initiative for that project. So why did we choose React Native? Well, it being native, that was a big thing for us. We wanted to provide that kind of UI, that experience to our users. That was important. We're a small team, cross-platform, reaching a big audience. It enabled us to do that out of the gate. We already had some experience with ReactJS in terms of web end, and that fed in very well into the mobile end of things, so that allowed us to ramp up quickly. React is a really nice way to work, using state as a source of truth, building reusable components. You know, it pays dividends down the line, and we found that. The vibrant ecosystem around React itself, and the developer experience of actually using it. You know, when you have your tooling all set up really nicely, the hot reloading, the time traveling, it's a great way to work. Some pain points that we've had with it are flaky environments. If you have multiple developers checking out from Git, doing an npm install isn't necessarily always going to give you a good build. Some ways we found to mitigate that is to make sure that you scope your package JSON versions to specific React versions. Don't allow it to just upgrade within the minor versions, because if you've planned features for a day and you come and you're doing that and you do that npm install, your whole day can be gone and you're in a world of pain. Yarn we haven't used yet, but we need to look into it ourselves, but we hear it's a good way to manage your dependencies, possibly better than npm, so that's worth looking at. React Native Git upgrade is a CLI that was released in the last few months to help with the actual upgrade itself with Git. So I'll step you through some of the actual workflow of using the system. You can see examples of journalists here who have signed up and are tweeting out to their users to actually send them some photos. This is the app. A user is able to open that up, browse through their camera roll, choose a location for the event where it happened. We also send the metadata that's attached to the photos as well, so we have the GPS coordinates if they're available. They can attach some actual text about what's happening. They can choose a specific journalist that they want to send that to, or they can send it to all journalists on the network, and they can upload that. The rough and ready journalist dashboard, still very beta, not React yet, but we want to get there. Ultimately, if an image comes in to a journalist through this dashboard, it has gone through our image verification process, the Python stuff that I mentioned. There's a rules engine there. There's machine learning. And ultimately, if it's in that photo inbox, a journalist can have some confidence that they can trust it. Obviously, they can actually dig down deeper and actually investigate that particular photo a bit more. We lift all the metadata that's available to us and allow them to do a bit more investigation. We do some clever things like cross-referencing with publicly available data. For example, like the weather at the time. If we know where the photo was taken, we can tell the journalist what that was. They can do the kind of visual cross-referencing. We also allow journalists to look at the social footprint of the user that sent in the info as well, so they can investigate whether or not they can trust that person. He's sitting in their audience, and I wouldn't trust him. We have had a challenge for onboarding users. If a journalist actually wants to bring a user directly to their profile within the app, so not the home screen. You download an app and you open it for the first time, you're getting the home screen. It's actually a challenge to open the app at a screen that's deeper than the home screen, what was the user intent. That's difficult to do cross-platform and consistently. There is a service there that enables us to do that, and that was Branch. It is worth looking at. It allows deep linking, so I'll just step you through an example of this workflow. If we're trying to onboard a user directly to a journalist profile, and they visit the journalist profile on the web, first of all, they're not even on a mobile device. Branch will allow them to put in their phone number, send them an SMS with a link. They click that link, and their device fingerprint will be recorded by Branch, and also where it was intended to send that user, i.e. the journalist profile. They'll send them off to the App Store, they'll download the app. The first time it's open, the app will reach out to Branch and say, hey, this device, just install the app, just open the app. Did it intend to go anywhere? Should we be sending it anywhere? And Branch will actually say, yeah, I recognize that device fingerprint. It was supposed to go to this profile. And all that happens very seamlessly. It's a great way to onboard people if they're not coming at your app from a mobile device. But likewise, if they are on a mobile device, it also enables you to do just the same. And yeah, Branch does a lot more than just deep linking. It makes you can actually expose some of the inner screen content to the web for SEO results. And it's probably worth taking a look at what it can do. Thanks for your time.
Thank you. Okay. Next up, Maja is going to tell us about React and D3.
Okay, hi everyone. My name is Maja. I'm a software development engineer, and I've been working a lot with D3 lately, and I've been working with D3 in React, so I decided to hold a small talk about the React and D3. So first of all, how many people here have worked with D3 before? Okay, that's quite a few. How many people have worked with D3 in React before? Okay, not so many. Okay, so just a brief introduction about a D3. Since this is a React meetup, I figure out that React doesn't need an introduction. So what D3 really stands for is data-driven documents. It's basically a JavaScript library that helps you build visualizations. It's really low level, so if you just need a library that will help you build a quick chart, it may not be for you, but if you really want to have control over your visualizations and like what you're drawing and how you're drawing it, then D3 is definitely the way to go. One definition I read somewhere on the web is that it's basically a jQuery for data visualization. So how it works. So D3 uses SVG to render graphics. It uses CSS for displaying and layout your component, and it uses DOM to embed visualizations. So basically you give certain data to D3, it attaches that data to the DOM, and then it mutates that data according to the rules that you specify. So the problem here is that it works by mutating the DOM element provided to it, which is not a problem by itself, but it's a problem if you take a step back and think about React reconciliation. So what React basically does, it figures out what DOM elements it should mutate, add or remove based on the DOM tree and application state. So what will happen if you add a D3 component inside a React component, React will mutate the element created by React. For example, if you say, okay, set the width of this element to 300 pixels, the D3 will do that. And then React will notice that you're tampering with its perfectly reconciled DOM, and it will get angry. And we don't want to make React angry. So there's a way we can solve this problem. Basically, if we take a step back and look at their common philosophy, is basically just give me a set of data, tell me how it should be rendered, and I'll figure out which parts of the DOM to update for you. Like, they both kind of work on the same principle. So I created a small demo. Let me figure out how to start it. So this is a line graph of HubSpot stock over time since 2014, since it became publicly available. So you can see that it went from like $30 to $60. So we're in the time. It's basically what this is. It's an SVG component which renders a line graph, and it's all wrapped inside the React component. So if I want to now change HubSpot stock to Google stock, now you see that the graph updated. I don't know what happened here. So the data changed, the SVG representation changed, but yeah. So I'll show you the code, what's happening in the background. Okay, so my next demo is what's actually happening here. So if this code looks familiar, yeah, that's the same Facebook demo app. So app is the entry point, right, for the application. I have two data sources, HubSpot data and Google data. Those are basically just two arrays holding values for the stock over time. Of course, in real life application, this would be fetched somewhere from some API. Here they are hard-coded, so basically just two arrays that are set in the state of the component, and it sets changes as you click buttons. And then I'm passing this data on to the chart component. Now, chart component is a React component that takes this props through props, and it has in component did mount. So first time we call this component, it creates the chart. Chart is basically just a JavaScript object. It's a wrapper around D3 chart, but it's a pure JavaScript object, and then it creates this object with the state, chart state, which is actually just the props that it received from its parent. And then in chart, so this is where all the magic happens. Chart component has three methods: create, update, and to draw, which does the actual drawing. But you see that create and update are similar methods to React methods. So in create, I create the SVG element and then set some properties that it will need later on. In the update, I basically just take this SVG component and then I call the draw method. And then in the draw method is where all the magic happens. So I set the domain for the x-axis, for the y-axis. I take the actual data, I pass the data to the component to SVG, and then I add the title, and then it draws. Yep, so this is in short. I have a full code on GitHub, but I forgot to include the link to that. So, but if you're interested, I can definitely tell you more after this talk, and I can provide some more information about this. Thank you.
Thank you. Thank you very much. So next up, we have a ReactJS Dublin veteran.
Starting from the very
starting from the start. We also have to kill mirroring.
Yep.
So Claudio is going to tell us about React Fiber. I think we'll probably have to kill mirroring up here. Over here. Go.
Whoa.
Whoa. We lost it completely. Do we see it? There it is. Cool.
Thanks, Kia.
Thank you.
All right, so I'm Claudio. I'm a software developer, and I'm going to talk to you about React Fiber. How many of you know about Fiber, what it is? Cool, that's not nil, so. So I'm a software developer. I worked in various companies, and now I start working closer to React. And really passionate about this library. I was actually a very big opponent of it. I was a big Angular 1 fan in the past, you would be able to tell. And then I became more and more interested into that by talking to Pete Hunt and then looking at the various alternatives that existed in the ecosystem, all the various libraries like Redux, then React Router, you name it, then virtualized. Some of the challenges that React had were solved by third-party developers. So open source community went a long way to address problems that were into React, but some of the problems were still inside React. And so this is where people who were outsiders, like Dan Abramov, started looking into improving React from the very core. And so now, pretty much almost done, there is a kind of a new way to build and create components using React. Before we get started, we need to familiarize ourselves with a few core concepts. Do you all use React? Yeah, great. So the main concept is the virtual DOM. So instead of just flushing all the changes to the DOM when re-rendering components, React calculates this in-memory model of components. And so this is called the virtual DOM. And then there is a step of reconciliation. So it looks at the DOM that exists on a document and checks if it matches the in-memory representation created in the virtual DOM. If it doesn't, then it updates selectively. The algorithm is very simple. It's checking attributes, it's checking component types, and so. And but that's pretty expensive still. So even though you do your due diligence, you implement your component update and return no false to bail early, that still requires React to do a lot of calculations. And so even though the model is a pull versus push, so instead of telling developers when you have data, you update the view, it tells when you have a new data, you just update the state, and then we'll pull the data for you and re-render the component. It's not enough. So all the changes that are essentially state transitions, even with the use of immutables, even with the use of wise optimizations in, what you call it? Can't remember right now. But the user shield component update or pure render mix-in and so on, it's not enough. And that means the UI gets slower and slower over time. So the legacy kind of core algorithm of React is called stack. So it's synchronous, so it sequentially goes through the hierarchy of components and starts calling render, render, render on all of them, calculates the memory representation of the components, and then checks if they match the previous model. At that point, then, it recursively descends into the components. That means if a component inside render renders further components, that means it has to descend into that. And the strategy to perform that operation is recursive in nature. So that builds onto the stack, consuming more and more memory as it goes through. So if you think about the kind of the relative size of a normal UI, that means there are thousands of components probably. And then after rendering, it has to step into the reconciliation phase, which is essentially matching and comparing the two in-memory and DOM representations of the target, the to-be scenario, and the as-is. So this means the app grinds to a halt. So if you develop anything like scrolling or touch interfaces or anything that has a vaguely complex animations, you'll see start jank. So things will start flipping, and you know, I'll show you with a demo what that means in concrete terms. It's got a heavyweight context for the way things are implemented. It does a lot of memoization. So that means it calculates data and stores that into properties, into a context. It can't be split in chunks, so it's essentially a monolith. It calculates everything at once, every single time there is a change in state in any component in the chain. And it's built with, well, it was a very clever one, but probably shows its limits because it's growing overweight, using a Java-like enterprise-y architecture, using object orientation, method dispatching, context switching, and so on. And there are very good notes by Sebastian on GitHub if you're interested into the design principles and the bottlenecks that they found into React that motivated and informed the creation of Fiber. So essentially, they took a few probably months to think about how to rewrite the core React algorithm, and they came up with this Fiber. So you see there is probably somebody is really passionate about knitting there, and yarn. Fiber is essentially a complete rewrite of React core. The basic concept behind Fiber is that instead of telling components what to do or what they should look like, or performing operations as in atomic units of work, they are instead representations of the work that has to be done. So the Fiber could be considered to be a unit of work, essentially. Another interesting point is that the reconciliation is asynchronous, so it's not synchronous and blocking, and can be split into different chunks. And although, nevertheless, the atomic commit guarantees that all the data on the page when the DOM is reconciled will be consistent. So there will be no patches of different data that's inconsistent because it belongs to a previous state. And so, again, goals that inform the implementation are be able to pause and resume work when an animation frame is available, and then using primitives that we'll see shortly to resume. Assign priority to different types of work. If you ever work with virtualized, you'll see that probably there is some data that's not really important to calculate and display and reconcile right then. And the reuse previously completed work, because if you describe a unit of work as an abstract object, you can pre-calculate it and reuse it later on if it matches the previous calculation. And even so, even abort work that's no longer needed. There is a concept in React called batch updates, which is not really used at the moment. It will be more and more used as time goes through. And so internally, it uses a request animation frame to actually draw on screen, but also request idle callback to schedule work that has to be computed. And it is able to calculate the time it takes from one request animation to the other to actually interrupt work and resume at the next time slice. It's iterative, so the structures behind it are very lighter, much lighter. So instead of calculating a really deep structure of components, it's a linked list. So it really probably turned out to be a good bet to study those in computer science. And at its core, it's very, very simple. It's simply a white loop with two main loops to reconcile and update that are literally traversing the tree of components or the representations. And so, as it pros, it doesn't drop frames. It delivers on the promise, and I'll show you in a minute. Splits work across frames, so whenever there's a calculation that takes more than one animation frame, it will be interrupted and resumed later on. Commits only when the work is complete, so no inconsistencies, and can deprioritize work that's off screen. Cons, so there is pretty much very little low-hanging fruit. So if you're interested in contributing to React core, there's very hard bugs that only happen in obscure parts, like when we saw the set state into components did updates, or even set state inside another set state, or weird things like that. Better tooling is needed. The React core team is still working on integration with dev tools. It's very, very difficult to reason about, essentially because it's a long while loop. So there's no context in a stack, so you have no idea where you are. And again, it's not guaranteeing instantaneous updates, but that's good because that means the UI doesn't freeze until the whole UI is calculated. So that kind of makes sense in the end. So big win. Again, since batched updates will be used more and more often, maybe using state inside set state is not a good idea. Instead, you should use the very little documented callback from hell there, where you get the previous state and prop, so you can incrementally update or essentially iterate from there, instead of assuming that the state at that moment is correct. And finally, you get a lot of extras, because since there is a chance to rewrite, these creative minds are coming up with a lot of improvements like error boundaries, which is essentially fallback components. Think about try-catch. Instead of a try-catch block, you get a component that's rendered on an error condition. Multiple components in render. This is something that drives anybody who's dealing with layouts, like grid layouts or flexbox nuts, or even tables. So you will be able to return an array of components. Great, hey. Or even portals for dialogues. There is a competing kind of library that we used called the Liberator. Portals are essentially areas of the page that are rendered outside of the context of the DOM. So for instance, think about dialogues. You don't want the dialogue to be embedded into the DOM at that very point. You want it to be rendered outside of the main hierarchy. So portals would be built in, which is great. And since they're decoupling the renderers from the main kind of calculation or rendering logic, the SSR will be better. Like nowadays, there is an Airbnb library that simply streams HTML right now. If you do SSR with server-side rendering with React Core, you have to calculate and reconcile with something that didn't exist. So essentially, you're calculating against the nil. But it's a waste of time. And so I'm going to show you a little demo here. So this is I'm not sure if you ever worked with a Sierpinski triangle. It's essentially like a huge structure. So the data behind this essentially updates every second. So this is a large tree with nodes whose value is updated every second and increments and then gets back to 1 when it gets to 10. But at the same time, the tree incrementally grows and shrinks. So you see there is a lot of junk here. The animation is not fluid. This is something you would not accept as a working app, not to mention like write video games with this. That would be totally like...
They're not using D3 for this?
No, not for this one. So Fiber delivers on the promise of having a fluid. This is in real time. This is calculated by React Fiber. It's amazing. So maybe you don't see the data updated in real time. Like if you, with a stopwatch, look at the numbers. Maybe they're not updated right then, but they're definitely yielding a really fluid animation. If you want, if I manage to use is it really tricky to do with one hand? So, oops, no. Crap. I always fail at this. Okay, so if you look at the profile, like let's capture 2 seconds, should be sufficient. We'll see what happens behind the scenes. So you'll see these are units of work. And between each animation frame, you see there is calculation. So let me zoom in. So you see oops, I'm scrolling too much. So you see it's recalculating every few milliseconds, and then it's yielding. So this is essentially what happened. It's calculating some reconciliation with the existing DOM, then it flushes to screen. There is a recalculation of style, animation frame, and so on. And then it resumes at the first available idle time. And this is really fluid. That guarantees that the UI is only updated when there is data available. At the same time, animation frames are not skipped and they're not dropped. If we go back to that ugly experience of the stack example instead, and we start capturing, we'll see something completely different. This is a really fast MacBook Pro, so I guess it won't be as bad as my demo that I was going to record, but still you see there is a huge flat yellow curve, so the flame graph is totally different here. You'll see the animation frame starts like around 400 milliseconds, and then boom, 800 milliseconds there. What's going on? We're dropping frames. So this is definitely not acceptable. And you see Fiber delivers on the promise of making animations and even transitions more fluid. So again, when is this coming? It's already mastered in React Head, so go check it out. It's really cool. And it will be expected to be enabled by default in React 16, which is probably coming very soon. And there is an amazing site you can check out for updates. It's essentially a test runner, that shows the, maybe, so, but still 98%. And these are really obscure bugs. So if you want to contribute, go ahead and look at those if you want to have Fiber faster. And finally, thank you very much. It's been a pleasure.
Thank you very much. So that was our final talk for the day. I think another round of applause is due for all of our fantastic speakers. As I said at the start, we will next time be going back to our regular longer talks, if anyone is interested in giving one, please do let us know, either by coming up to myself or sending us a message on meetup.com. We also, after each meetup, send a survey asking for feedback. Since this is the first time we did the lightning talks, we're particularly interested in hearing what you have to say and what you thought about the format. So please do fill that out. Now that thing's over, we still have some more beer, so we need to empty that out, I think. And I'm looking forward to chatting to each and every one of you. So thank you again for coming.